And here's the idea. Suppose I want to send you a bit, one bit of information at a time, and the bit can be either 0 or 1. But there's a chance that the bit could be messed up. There could be noise. In which case, I need to then come up with some kind of error-correcting code so that you can correct the errors. And here's a real simple, trivial code. It's called Hamming code. And instead of sending you just a single 0 or a single 1, every time I send you a bit, I'll send it 3 times. Right? So these are the real messages. The legitimate messages are 0, 0, 0 or 1, 1, 1. And if you get a 0, 0, 0, then you know I was trying to send a 0. But I sent it redundantly so that you would definitely not get an error. And if I send you 1, 1, 1, then you know definitely that I meant to send you a 1. But now, there's possibility for noise. And there's 8 possible messages that could actually come across to you, right? These are the only true messages that I want to send. But you could end up getting 1, 0, 0, in which case you can correct it back to say, well, you probably meant to send me 0, 0, 0. Right? But if you get a 1, 1, 0, then you go, well, you probably meant to send a 1, 1, 1. So what this, and I put it on this cube to show you that what I've done is I've taken one bit, which is either 0 or 1, and I've exploded it up into a 3D volume. And that's what I propose your perception of space is. You're perceiving a 3D world, not because there's an objective 3D. This is just the format of your error-correcting code. You live in the data matrix for fitness.
Why is it necessary to have standard Cartesian space to do that?
It's not. There's lots and lots of ways to do error correction and data compression. So it's only the vague. One thing that probably is going on is that evolution tries to do everything on the cheap. You could do far more sophisticated error correction than I just showed you. So there's going to be selection pressure to do the error correction as cheaply as possible. There's a trade-off. You don't want to get it wrong. You want to get the right fitness messages, but you don't want to spend too much energy on error correction. And so you try to get that happy medium. So if space is an error-correcting code for fitness, that means it makes a clean prediction. Think about this 3D cube that you're seeing right there. How much information could you jam into the volume of that cube? Actually, there's no volume, right? You can't stick information into the volume, right? So you're seeing a 3D cube here with a volume, but there's no way that you could actually stick information into the volume. Clean prediction of what I just said. You cannot, in the space around us, stick information into volumes. Clean prediction of what I just said. Now that might seem, aha, that's clearly false. But it's not. So how much information could you actually stick inside, say, the volume of that volleyball? Well, you might say I could stick a terabyte hard drive in there, then maybe another terabyte hard drive, and then I could maybe make them smaller. I could keep sticking information into the volume of that. What's the maximum amount of information in the ultimate that you could stick inside that volume? Well, it turns out we have an answer. Stephen Hawking answered this. And it's independent of the volume. The amount of information you can stick inside a volume of space does not at all depend on the volume. The volume is utterly irrelevant. You cannot use volume to store information. Only surface area. The amount of information is proportional to the surface area. It's called the holographic principle. It's one of the deepest, most profound discoveries in physics in the last 30 years. What this means is the following. Suppose I have a big sphere with a certain volume. I can stick as much information in it as proportional to the surface area of that sphere. But now imagine that I take 6 smaller spheres of equal size that just fit inside. I've illustrated it there. Now you can look, you can see that they have less volume than the whole sphere. In fact, they have roughly half. But they have more surface area. The 6 small spheres have less than half the volume, but they have more surface area than the big sphere. That means you can stick, and this is the universe we live in. This is not science fiction. This is not make-believe. This is not a novel. You can stick more information into those 6 spheres than you can stick into the big one. Now, if that's blowing away everything that you believe about space and time, that's my goal. That is my goal. Now, we can do this recursively. Take each one of these spheres, break it into 6, and keep doing it. Do it 20 times. Do it 30 times. After you've done it that many times, you can store a ton more information, billions of times more information, and the volume is essentially 0. That's the universe we live in. And the reason it's that way is because space is not an objective reality in which we live. It's an error-correcting code, a data structure that we inhabit. You are living in a data structure. It really is like the Matrix. So we take an evolutionary view. There are many fitness functions that are relevant to you depending on your state, the action that you need to take. You have finite memory and finite computational resources, and evolution is trying to keep them as small as possible. And in fact, it's making our brains as small as possible. We've lost 10% of our brains. Over the next 20,000 years, it's likely that we'll lose another 20%. Another 10% will probably be back to Homo erectus. So we're really trying, evolution is really trying to do things on the cheap.
Excuse me,
Yeah.
can I ask a question?
Yeah.
How do you know what the surface area of the brain has changed, though?
Well,
Can you repeat the question?
yeah, so there could be more folds. What we do know is that, I mean, the critical question is, I mean, our bodies have also shrunk from the time, you know, over the last 20,000 years. So the real thing that they look at, and this is what work by John Hawkes, an anthropologist, is that the EQ, the encephalization quotient, has gone down. So our bodies have shrunk, but our brains have shrunk faster. So that's really the thing that's going on there.
It still doesn't answer the information storage capacity.
Yeah, we don't have actually.
You don't know what the surface area of the brain is. You can't determine that from a skull.
That's right, because we don't have the soft tissue. But we do have, actually, I knew that this had to be the case before I saw John Hawkes' work, just based on the theory of evolution itself. So we don't have the soft tissue, but we have the theory of evolution, which makes a very, very clear prediction. When there's a strong social net and the selection pressures are lowered, then the brains will get smaller. So I actually knew that this was going to be the case before it actually came out. So we don't have the soft tissue, but the theory of evolution makes a very, very clear prediction here. And in fact, another prediction that I actually made before I saw the data, and they've confirmed this with the archaeological evidence, is that the shrinkage occurred most rapidly. This is looking at fossil evidence and archaeological evidence together. It occurred most rapidly where there were the social groups. Where there were large social groups, that's when we shrunk. Clean evidence from, clean prediction from evolution. So I actually was not surprised when I read this, because I was going, this is obvious. If you know evolutionary theory, this is just obvious.
Isn't that a correlation, not a causation?
Every scientific theory is fallible, absolutely. And if you have an alternative theory, that's great. Yeah.
I'm just curious, because when you're speaking about space, time, physical objects, causality not being fundamental,
Right.
it seems a bit contradictory because you seem to be arguing that the evolutionary view of us is what sort of explains how we have these perceptual illusions. But the whole notion of being little primates running around in a vast universe that are trying to procreate seems to be describing a world that is very much about space and time and
Right.
causality. So it seems contradictory.
Very, very good. So I'll even make that objection stronger. I've used evolution to show that physical objects such as DNA and organisms and resources are not fundamental. So I've used the theory of evolution to disprove the theory of evolution, so I've shot myself in the foot. Right? So here's what I've really done. So that's a very, very sharp objection. It turns out that the physicalist assumptions of evolutionary theory are not fundamental. What is fundamental is an abstract algorithm called universal Darwinism: variation, selection, retention. And the theorems that Chetan proved take that heart of evolutionary theory, the abstract algorithm, which Darwin, Dawkins and Dennett and others have pointed out is you can use it to evolve, for example, memes and other things. So things that are abstract, that are not physical, can also evolve. So the idea is we took the heart of evolution, the key insight that if you have variation, selection, and retention, physical or not, you will have evolution. And we asked, in that situation, what is the probability that we've evolved to see reality as it is, whatever reality might be. And that's where we get the precise answer. The answer is 0. So what we've actually done, this is the power of science. We can use our scientific theory, like evolution, to actually go back and refine the very theory itself and say, you know what? This part of the theory could be fine, but this part is definitely not. The physicalist assumption that DNA and resources exist unperceived is false if the rest of the theory is true. So that's the power of science, is to actually allow us to tighten up our concepts and our theories. So the idea then is our perceptions are all about data compression, and error correction. And we're trying not to misread fitness, so we have error correcting codes. And so this is going to lead to the redundancy of space and the fact that you can't store information into volumes. It's also going to lead to symmetries. Whenever you have error correcting codes, symmetry, group theory and symmetries are the heart of it. And so this is when physicists are looking at the symmetry groups that are critical to their physical theories, they're not looking at the objective nature of reality. They're probably looking at the symmetry groups that we happen to have evolved for our error correcting and data compressing perceptual systems. So symmetries are critical to physics, and we're studying the symmetries of our own data compression and error correction. And as Chetan proved, the symmetries of our perceptions, the fact that as I move around, I can use the Euclidean group to predict exactly what I'll see as I move around, tells us nothing about the nature of reality. Absolutely nothing at all. It does tell us, we're claiming, something about the nature of the error correcting and data compression codes that we're using. And physical objects, then, are a solution to the problem of representing fitness functions in a way that we can actually use. So we have all these complex fitness functions, many, many different ones, and objects like a table and a chair are not our perceptions of true physical objects that exist in reality. Objects are a solution to a data representation problem. We have all these complicated fitness functions. It's too much information for us. We have finite resources. So we need some kind of perceptual format that will give us enough information about fitness to keep us alive, but not so much information that we're overwhelmed. And objects are a solution to that optimization problem. The reason we see objects is because they are a compact format for giving us information about fitness and have nothing to do with truth. So our perceptions are satisficing representations of fitness, just enough to keep us alive.